In this video, we're going to talk about station models. If you look at this weather map, you can see that these teal things right here, these are actual station models on this real-time weather map. You can see February 24th, 2015, and the time span, this is of the Northeast. So you can look here. The teal thing is a station model, and then these green numbers to the side are actual numbers that represent the current weather conditions at specific locations. So our goal for today is to help you figure out what all of this information means on one single station model, and hopefully you'll be able to draw one by the end of this video. So the first thing we want to do is we want to follow along our station model instruction sheet. We also want to have page 13 out of our reference table, which guides us through all of this information. So if you could have that out, that would be very helpful. As I go through, I'm going to kind of talk about this stuff, and then you should be drawing things in your worksheet. So the first thing is that anytime you have a circle that's drawn, that circle is going to represent a specific location. So if you think back to the weather map I just showed you, all of those teal circles that were on there represented specific locations. For example, Binghamton, New York would have its own specific station model. The next thing would be the wind direction. A line is drawn on the circle to represent the direction the wind is coming from. Keyword here is coming from. Okay, all winds are named from the direction they come from. So this right here is the tail on the station model, and we can see that the wind direction would be coming from the northeast. So you should write northeast in there because this is the compass direction that this tail is pointing. So whatever direction the tail is pointing, that's the direction the wind is coming from. The wind speed is also indicated on this tail. Okay, these things called feathers are actually drawn in a way to represent how fast the wind is blowing. So if we look here, a whole feather, which is always drawn on the end of the tail, represents 10 knots. A half feather, which is always drawn further down the tail here, is worth 5 knots. If you look at your reference table, you can actually see this. So let me show you. So I'm on page 13 here. We can see that in this one, you can see the whole feather, which is longer, which is 10 knots. Our half feather is 5 knots. So if we were reading this station model on a weather map, we would know that the wind was blowing at a speed of 15 knots. 1 knot is about 1.15 miles per hour, but mostly we record that in knots. So if I wanted to do 25 knots, all I would do is I would add another whole feather here, and all I have to do is add them up, and I get the speed that I'm looking for. Remember, if it is only 5 knots, you should have this half feather a little bit further down so that we know it's 5, not a whole feather, and you just drew it short. The next thing is cloud cover. What you do for cloud cover is you shade the percentage of the circle that's equal to the percentage of cloud cover. So the term overcast means that it's 100% cloudy, so the sky is filled with clouds. So what you want to do is you just want to shade the whole entire thing here. Mostly cloudy is 75%. So what you would like to do, you should probably shade in a clockwise manner. You're going to shade 75% of the circle. Partly cloudy is about 25%, so you would shade clockwise again, about 25% of that. And clear is 0%, so you wouldn't shade anything. Sometimes what you will see is a circle drawn in the center just to show that you didn't forget to do that, but that also represents clear sky. Air pressure or barometric pressure is our next weather variable. This value is always represented in millibars, but remember we learned in class that you can convert that to inches of mercury. But always on a station model we're going to represent it in millibars. Now to write it, what we have to do is we have to take the last 3 digits of the air pressure and eliminate the decimal. So what we would do here is this example says 1020.6 millibars. We don't want all of this on the station model. So what we would do is we would just take the last 3 digits, which are 206, and we would eliminate the decimal, okay? And we would write it right on the top here. So we would write 206 on the top. Same thing with this one. This is 989.4. We would eliminate the 9, take the last 3 digits, eliminate the decimal, and right at the upper right, I would write 894. So please do that on your notes. Now to decode, what if it's already in this code? So we can see here that my code is 115, okay? this number, 115, is less than 500. So when it's less than 500, I'm going to add a 10 to the front and then add a decimal between the last two digits. So my pressure here would be 1011.5 millibars. So I'm adding a 10 to the front and then I'm adding the decimal back. Okay, so just like you see up here, we had it in real form. We took the last three digits, removed the decimal. Now I want to put it back. I want to add that 10 and put the decimal between the last two. If that number is greater than 500, which you can see here in 876, I'm now going to add a 9 in the front. Okay, so instead of adding the 10, I'm going to add the 9 in front. So I'm going to write 987. Then I add the decimal 0.6. We always add the decimal between the last two digits. Next thing would be the temperature. Temperature is placed in the upper left section of the station model. It can be in Fahrenheit or Celsius. It's usually in Fahrenheit because that's what we use here. But it needs to be the same for all your temperatures. So your dew point needs to be in Fahrenheit if your temperature's in Fahrenheit. Or if your temperature's in Celsius, then your dew point needs to be Celsius. It needs to be the same on the station model, okay? So the dew point we're going to put in the lower left. Again, temperature is in the upper left. Visibility is plotted between temperature and dew point, so right smack dab in the center. This is the distance that we can see in miles. So if we look at our reference table here, we can see that this one says 28 is the present temperature, 27 degrees Fahrenheit is the present dew point, and then our visibility smack dab in the middle, you can only see about a half a mile on this for this station model, okay? Notice here there are no units. We only put the number for these variables. Current conditions are symbols that are located on page 13 of your reference table. It looks just like this, so I've copied it into this box. You're going to place this between temperature and dew point right by the visibility. So if it is drizzling, raining, hailing, there's freezing rain or snow, you would put that symbol right in between those variables, okay? Now, if there is no present weather, so it's not doing anything outside, you would just leave it blank. Precipitation, you are going to put the inches of precipitation for the last 6 hours, okay, to the lower right-hand side of the circle. Okay, so in the last 6 hours at this location, there was 0.4 inches of precipitation. Really important here, you'll notice that there is a decimal in this one. So you want to make sure there is a decimal placed in this one. For everything else, we're really not using that. Last thing on our station model is the pressure trend. The pressure trend will be placed in the middle right side of the circle. And this is for the past 3 hours of how the pressure has been changing, okay? So what you're going to do is you're going to remove the decimal, and then you're going to add a rising or falling slash at the end and add a plus or minus sign to the front, okay? So let's look at this first example. It says the pressure for the last 3 hours has been rising 1.7 millibars. So what we would do is we would first need, since it's rising, we would need to use the plus sign, okay? So right here we would write plus, and then what we're going to do is we are going to write the value by removing the decimal, okay? So that sometimes is a little strange, but you're going to write plus, and then we're going to remove the decimal, so that would be 17. And then we have to add in the slash, which is the rising slash. So we'll add in the rising slash. So we should have what you see down here for this example, plus 17 and rising, okay? Go ahead and try the falling. What you would do is, again, falling, you would make sure you have the negative sign now because it's falling. You would remove the decimal, so you'd write 105, and then you need to add in, you're going to add in the falling slash, which is right here, okay? So you would go, again, negative 105 and then falling. Last thing is, what if the pressure is steady? Well, all you would do is you would just do these two dashes right in the center. That means in the past 3 hours, the pressure has not changed, okay? Now, sometimes you'll have to decode, so they'll ask you by looking at the station model, what is the pressure trend, or how much has the pressure changed within those 3 hours? Anytime you see the plus sign, you're going to write rising, so we know this pressure is rising. It says 17, but remember, we took the decimal out from up here, so we have to put the decimal back in, so it's 1.7, and then rising is still the plus sign, so we don't have to write that twice. So the pressure trend for the past 3 hours for this one would be 1.7 millibars rising. Okay, so we'll do a few practice with these tomorrow during class, but make sure you have everything filled out. If you need to rewatch anything, feel free to do that as well.